Hello, welcome everyone. Thank you for attending today's webinar, The Role of CCUS for Industries to Reach Net Zero Emissions. Just before we begin, I'd like to cover a few housekeeping items. So we're using a platform called On24 to hold this webinar. If you're not familiar with it, everything you can see on your screen can be moved and resized to your preference. For example, you can expand the presentation slides to full screen if you wish. To submit questions, which we do encourage you to do throughout the webinar, please use the Q&A tool, which I think is on the left-hand side of your screen. We have a Q&A segment later on in this webinar where we will try to answer your questions. For the best viewing experience, we recommend just closing any program or browser sessions running in the background. And finally, we are recording this webinar, so the link to the recording will be sent to you afterwards. Great, so thank you again for attending today's webinar, which is co-hosted by SBE Gaia, OGCI, IAGP, and IPECA. My name is Amy Collins. I'm the Climate Change Manager at IPECA. So very briefly, for those of you who are not familiar with who we are, IPECA is the Global Oil and Gas Association for advancing environmental and social performance across the energy transition. We were founded in 1974 at the request of the United Nations Environment Programme to develop a shared industry response to environmental and social issues. And today we remain the industry's principal channel for engagement with UNEP. And we also lead in mainstreaming sustainability across oil and gas, as well as alternative energies. So some of you may or may not know, but IPECA has been working on CCS for a long time now. We held our first workshop back in 2003. And then since then, we've held numerous events and developed a few guidance documents to support the industry to understand how this technology could contribute to net zero targets and meeting the goal of the Paris Agreement. So we are seeing more CCS projects emerging around the world now, but it's still not clearly at the scale that it needs to be to keep global warming to 1.5 by mid-century, which is the Paris Agreement goal. So that leads us to today's webinar. We've been holding this webinar series over the last 10 months to share knowledge and good practice and consider novel and different ways to accelerate and scale up deployment of CCS. So far in the series, we have held 3 webinars, one on carbon take-back obligations, one on technological solutions for negative emissions and CO2 removal, as well as one on the Midwest Regional Carbon Initiative, which is a dedicated CCS study in the United States. If you're interested in any of these webinars, listening to them, we've got the recordings. These can be found in the related content box on your screen, and they're also available on IPECA's website. So today's webinar, we will be looking at the important role CCUS could play for industries to reach net zero emissions. Industries such as oil and gas, steel, cement, and petrochemicals account for a large number of CO2 emissions, which we all know, but they are also among some of the hardest to abate in the energy transition, in the energy system. But demand for these materials from these industries is going to remain strong to support emerging and growing economies, which is why a portfolio of technologies and approaches will be needed to address the decarbonisation challenge. And CCUS is one of these technologies that could play a critical role in the sustainable transformation. So that's what we're here to discuss today. And we're joined by a fantastic panel of speakers from these industries who will share their insights and discuss the current status of CCUS developments within their industries, challenges they're facing, and where there might be some opportunities for collaboration as well. So Hassan Moonsami, who is the CCUS Program Manager at OGCI, and he's going to give us an overview of the current status in CCUS scale-up. We will then hear from Andrew Purvis, who is the Director of Sustainable Manufacturing at the World Steel Association, and then Philip Dusmet, who's the Director of Petrochemicals Europe at the European Chemical Industry Council, and then finally Rick Bohan, who is the Senior Vice President Sustainability at Portland Cement Association. We've then set out quite a bit of time in this webinar for a Q&A and discussion, which will be moderated by Arthur Lee, who's Chevron Fellow and Principal Advisor, and he's also Chair of IPECA's CCS Task Force. As mentioned, we welcome your questions. We want to have a good discussion, so please submit these at any time in the Q&A box. And with that, I will hand straight over to Nivasan.
Great, thank you so much, Amy. Great, let me briefly talk you through CCS projections today. These are made by the IEA. So today we have around 35 commercial CCS facilities that are in operation with the collective capacity to capture almost 45 million tons CO2 each year. The IEA believes that the CCS capacity needs to increase to 1.2 gigatons per year in 2030 and 6.2 gigatons per year in 2050 in the net zero emission scenario. There should be plans for more than 130 new CCS facilities, and these were announced in 2021, with a total of 260 of these facilities now in various stages of planning and development worldwide. If all of these projects were to proceed into operation, this would account for around 260 million tons of CO2 captured in 2030. This then represents a six-fold increase on the current 2022 deployment, although this is only 20% of what is required in the net zero scenario of 1.2 gigatons by 2030. In comparison to the IPCC projections for CCS, the net zero scenario uses 6.2 gigatons of CCS in 2050, while the median of the IPCC scenarios sees around 17 gigatons of CCS in 2050. The key areas to scale up deployment for CCS that the OGCI finds is enabling policy mechanisms to deploy CCS at larger scale, finance for CCS, such as ESG finance, voluntary and compliance carbon markets, and general access to finance for CCS. We also need investment level and bankable geological storage assessments, such as using the SPE SRMS storage resource management system to better understand geological storage globally. Let me move on to the next slide. Great. What I'm going to talk to you right now is a cement CCS case study that the OGCI had done. OGCI had researched most of the sectors, but this is a cement example today. So jointly with BCG, a CCS hub assessment was done on 56 countries. We had identified 293 full-scale CCS hubs, and this accounted for approximately 7 gigatons of annual CO2 emissions. These hubs were then optimized for costs, which identified minimum cost emitters. 154 preferred scale hubs were identified at a cost below $100 per ton. On the map, these hubs are identified by the green and gold dots, and this accounts for approximately 1.5 gigatons of annual CO2 emissions. From these 154 preferred scale hubs, 78 of these hubs included cement and lime CO2 emitters. The resultant cement and lime CO2 emissions abated by these 78 hubs under $100 per ton amounts to approximately 190 million tons per annum of CO2 emissions. This is from a hub's cost optimization perspective, and the cost is all the way from capture right down to storage. Looking at the overall hubs where no cost optimization was done, there are still some hubs under $100 per ton. 122 of these full-scale hubs under $100 per ton included cement and lime emitters, and this abated approximately 360 million tons per annum CO2 emissions. These hub costs will however be higher than the cost optimized hubs described earlier. The overall study that the OGCI had done also includes hubs in various cost tiers. This also includes hubs above $100 per ton, abating annual cement and lime related emissions of approximately 620 million tons per annum. That was just a general summary of some of the work we had done on cement-related CCS hubs, though we've done hub analysis on all the sectors, and of course, you are free to view this on OGCI's website. But I'd now like to hand over to Andy.
Thank you, Nivasan. I'm delighted to be here. Let me just go on to my slides. So I'm Andy Purvis. I am with the World Steel Association, and I want to just take a few minutes to give a bit of introduction to the association and the role of CCS potentially within our industry in the lead up to the Q&A a little bit later. I won't dwell on World Steel. We're effectively a global trade body for the international iron and steel industry. Our members in all countries, and if you take our total membership with associations, we're about 85% of global steel production. Our headquarters is in Brussels, but we also have an office in Beijing, where, of course, half of the world's steel is coming out of China now. The essential problem we have within the steel industry looking forward is steel enables the modern world and enables decarbonization, which is a great thing. But the issue is, as demand continues to grow, we can go so far by recycling old steel, but the availability of old steel is really a function of yesterday's production, which was less than today, and the life of a steel product, which is typically 20 or 30 years. So we're going to have this lag in recycled material versus where we need to be in terms of demand. And I think it's generally accepted by, say, 2050, there'll still be a demand for 1 billion tons a year of virgin steel or steel from rocks versus steel from scrap. Now, there's only so many ways you can turn iron ore into metallic iron. Right now, we use the blast furnace or gas-based DRI on a slightly smaller scale, but both of these lead to the release of CO2. Gas-based DRI is a bit less a ton. The blast furnace, on average, is about 2 tons a ton globally. And clearly, with increasing demand, this isn't a sustainable way forward for the industry to progress. Happily, there are alternatives to using carbon and coke and coal effectively, which is what we do now. And they kind of fall into 3 areas. One is to keep using carbon, but prevent the emission of those harmful gases into the atmosphere. So that could be achieved using CCS, CCUS, or potentially sustainable biomass, or even some combination thereof. The second would be don't use carbon, use hydrogen, and then instead of CO2, as an outcome, we have H2O, which is clearly a better situation for the climate. And the final would be to use some more direct electrification, more akin to the way that aluminium is manufactured today, smelting-based process. This is clearly very simple, and often I think we'll find there'll be a combination of these things. But I think the point I really want to make is there isn't a single solution, and whatever is applied in a particular company, in a particular region or country, will really be determined by local conditions, which include the availability of resources and policy support. You know, I sit in Europe, so I could understand if someone is sitting looking at the steel industry in Europe, that hydrogen is the answer. Well, maybe largely in Europe, it may be the answer, or a large part of the answer, but it's not the answer globally. We will really, given the size of the issue, we need every solution we can put our hands on. And in terms of where CCS is in steel, many people watching this, I think, will know about the Emirates Steel CCS plant, which has been operated since 2016, and probably think, well, that's it. Well, there's actually a lot more going on than that, and it's probably accelerating in recent years. You know, we started doing CCUS back in the 80s within the steel industry, and that's still happening in Mexico and being expanded. That CO2 is going into food and drinks. But really, I think since 2019, 2020, we've seen an increase in the number of projects interest in CCS. And I'm not going to go through all these individual projects. All the data's available on our website. And if we could talk about some of these probably in the Q&A. But I guess the message I would want to give is looking at these projects. First thing is they're global. They're in from Japan, India, the US, Middle East, China. And increasingly we're seeing partnerships. And we'll probably come back to this again, I hope, in the discussion. You know, a lot of these projects are research agreements, cooperation agreements between the steel industry and other entities with knowledge of the subsurface and how to manipulate oil and gases, like Shell, Equinor. You see on there BHP as a miner, you know, Exxon are in there, also Sinopec and BASF. So I think partnership is important. So that's probably, I'll probably stop there and look forward to the discussion. But my key message here, possibly, that is the steel industry is not all about hydrogen. Despite what you might have heard, we need everything, and CCS is and will play a vital role in decarbonizing emissions from our industry. I'm going to stop there and seamlessly hand over to Philip. Philip, it's all yours.
Okay. Not sure I can find my camera, which disappeared. Okay. So I will tell you about the role of CCS and CCU for the chemical industry, and then more specifically petrochemical industry. As CEFIC, we have officially expressed our support for the European ambition to become climate neutral by 2050. We're probably the fourth biggest CO2 emitter in the EU 27 after steel, cement and refining, and petrochemicals, which is basically the organic chemicals part, the large volume. We're basically responsible for about half of the direct emissions of the full chemical industry. We have carried out as CEFIC a study in 2021 to see what are the possible pathways to reach climate neutrality in 2050 in Europe and what would be the cost for that. The answer that came out, we've looked at 4 scenarios. There's no single silver bullet that will solve it all, and we need all a combination of solutions. The solutions are in electrifying the way we generate heat, in using more biomass, in having more circularity, so recycling plastics, and the CCS, CCU plays an important role in that. What we find in the model is that we will remain an emitter of CO2. So to reach carbon neutrality, we need some negative offsets. And a large part of these negative offsets would be, for instance, by generating steam, burning biomass, and then capturing that CO2 from the biomass and storing it. We have basically, this is an overview of the challenges for and the opportunities for petrochemicals. So we have this Green Deal that on the one hand gives us a lot of challenges, but also proposes some opportunities. You all know about the Repower EU following the high rise in prices of energy. We have the US Inflation Reduction Act that might create pressure on European production. And we've basically in petrochemicals looking at 4 main areas which are focus. We looking at our feedstock that goes into our steam crackers that are basically the start of the petrochemical and chemical value chain. So we're looking at diverse feedstocks. We will still need fossil hydrocarbons, but we will see biomaterial coming as a feedstock. We will see recycled waste plastic that is paralyzed that will go into our cracker. But we may have methanol coming in as a potential feedstock, methanol, green methanol. On our products, we have a lot of challenges because there is all this talk about safe products. And so we need to look at the portfolio of products, and there might be quite some impact on safety. Take the PFAS discussion that could affect our industry. And we still need to remain competitive. Again, recycling will change the products we have to make. We have energy where we look at maybe electrifying more, but then we'll need infrastructure for that. And we basically need that energy low cost and abundant. And then there is the carbon management. So on the one hand, one of the issues that we have is the products we produce, and main products are plastics that you all know. When you burn them, end of life, you get CO2 coming. So one way to prevent our products as ending as CO2 is by recycling them and reducing our demand for virgin hydrocarbons. But you'll see CCS and CCU are also on the agenda. And we have also people skills, innovative technologies, all things that we need to reach these objectives of 2050. Now, on CCS, we have some concrete or projects under development. We've just given two here. We have the Port of Rotterdam, the project Portos, which is a consortium of many companies, and you can see the companies on the bottom that would sort of collect CO2 and then store that in empty gas fields. That could start as early as 2024 with an annual capacity of 2.5 million tons of CO2. And then there is the project Antwerp at Sea, where 7 leading companies, energy companies, and the Port of Antwerp are working together, investigating technical and economical feasibility of building a CO2 infrastructure in the Port of Antwerp, with the aims to keep CO2 of atmosphere and capturing and either utilizing or storing it. So probably going to Norway. But you see there's more CCS projects that are on the radar. Now, one thing that is special on petrochemicals is, and here I'm making the example with synergy with the steel sector, is we're basically, we know the chemistry and we can make chemistry with CO2 and hydrogen. That CO2 could come from steel mills that they are producing in their blast furnace gas and their coke oven gas. We can combine that with hydrogen, and we can either make syngas. From that syngas, we can make methanol. And from methanol, we can make the basic products of the petrochemicals. We can do ferment to ethanol. We can do Fischer-Tropsch to naphtha that we can use as a feedstock. And we can also do CO chemistry to ethylene and other interesting molecules. So for us, it's not only CCS, but we see quite some potential for CCU replacing our fossil hydrocarbons by basically using the carbon that is in the CO2 to make interesting petrochemical molecules. I'll stop here and available for further questions, and I'll leave it to Rick, I think.
Thank you, Philip. I appreciate that. So my name is Rick Bohan, and I am the Senior Vice President of Sustainability at the Portland Cement Industry. My sole role is to implement our roadmap to carbon neutrality. And a key component of that roadmap is carbon capture. There's no question about it. When we talk about cement manufacturing, we have two primary sources of CO2. The top equation represents what we call our chemical fact of life. So we are essentially taking carbonated materials, typically limestone, and we're decarbonating those materials. That represents 60% of the CO2 footprint in the US cement industry. Without that initial reaction, we don't make cement. It's really that simple. And to do that, we're using combustion because it's a very high temperature process. Temperatures of roughly 1500 C, 2,800 degrees Fahrenheit. So 40% of our CO2 footprint is coming from combustion. Today, the United States cement industry represents, of all the major emitters in the United States, 2.5%. However, we look at our CO2 footprint very seriously. And again, a key component is carbon capture. PCA, along with our members, have been working very diligently with the U.S. Department of Energy. And there are a wide variety of projects that are ongoing right now in terms of carbon capture. And I've listed a few of them. You'll notice a couple of things. Firstly, although these are wonderful projects, they're very small projects. Essentially, they are either pilot projects or they are front-end engineering design projects, what we call FEED studies. You'll also notice that the money is really fairly small in terms of what the financial commitment is. It may seem big to an individual company, but in terms of the scale of the problem that we're dealing with, it's relatively small. You'll also notice that there is no single capture technology that that's been identified. That's because the U.S. cement industry, we have a very different emission profile than other high temperature industries. So what works in power generation might not be the optimal solution for the U.S. cement industry. I'd also point out, at least today, there are no at-scale capture projects anywhere in the world at cement plants. There have been a couple that have been announced, but in terms of actual operation at scale, none of these projects are, or none of these capture technologies have been installed. Well, why is that? I think there are three really big obstacles that, and by the way, I think you've heard them alluded to already, but there are three really big obstacles, particularly in the United States. The first one is power. Putting carbon capture at a U.S. cement plant will double its energy consumption. Let me say that again. Putting carbon capture at a U.S. cement plant will double its energy consumption. That leads to the question of where will that energy come from? Most areas of the U.S., we don't have a robust or reliable grid, and we're not the only industry looking for these power sources. And of course, every industry is trying to find newer renewable sources of energy. The other esoteric things that people might not think of is that, you know, when you double your energy consumption, you'll also require not just transmission lines, but things like industrial transformers. Today in the US, the lead time for an industrial transformer is measured in years. Pipelines. Once you do have carbon capture installed, not every plant is in a geologic area where they can store it underground. In many cases, that's got to be compressed, liquefied, and transported to a remote site. The US Department of Energy estimates that the United States, for all carbon capture, will need roughly 70,000 miles of new pipeline capacity. None of that has been built yet. That's a real obstacle. And then finally, permitting. The U.S. cement industry is one of the most highly regulated industries, not just in the U.S., but worldwide. And there's real questions about what type of permit we'll be looking at to operate, to install carbon capture. So things as simple as what type of equipment, how is it monitored, how do you ensure compliance, what type of reporting requirements are involved? So these are all the issues that we've been bringing to academia, to the research institutions, as well as government. And at the Portland Cement Association, again, this is a key component of our roadmap to carbon neutrality. Our message is always, for whatever group we speak to, help us help you. With the right policies in place, with the right infrastructure in place, we can make carbon capture happen within this decade. Without those, we continue to push that time frame out further and further, and we can ill afford to do so. So that's just a very small snapshot. I would recommend folks to go to PCA's website to look at our roadmap to carbon neutrality at cement.org. And with that, I will turn it over to Arthur for some wrap-up comments. Thank you.
Great. Thank you very much, Rick. I'm here to moderate your questions and questions, and of course answers from our panelists. So far, I have not had too many questions yet from the audience, but I do have one that I would like to ask. It's by one of the audience members. It has to do with I think the scene setting, landscape setting that NITS Mr. Munsami. I always know NITS as NITS. NITS, if you don't mind starting to address the question, it's really about the scale of the of oil and gas and hubs and all that you started talking about. What is that initial kind of cooperation that we envision working with our colleagues here in steel and cement? You mentioned cost as one of the major drivers. Can you elaborate a little bit more on what kind of approaches we have done so far in our industry to make this happen?
Great. Thanks, Arthur. That's a very, very relevant and rather detailed question. So the first thing we looked at is how we try to drive the cost down of the hubs via economies of scale. So essentially trying to find a large as possible geological storage site, which then caters for that economies of scale. Then for the capture side, trying to incorporate as many CCS emitters, as many CO2 emitters as possible. So we'd look at a minimum sized hub of around 2 million tons per annum. The key thing is if you want to get the hub at a lower cost as possible, you'd want to have CO2 emitters that are high concentration, high purity, so high partial pressures in CO2. So the capture cost is as low as possible, though that does not prevent you from including other CO2 emitters which has low concentrations, because as you collectively combine all of them, the economies of scale will then allow you to bring that entire hub cost down as low as possible. We try to target hubs of around below $100 per ton as a key target, though there are certain hubs across the world where the storage costs could be a little higher, and the capture costs, due to the constraints in terms of concentration of CO2 and the lower partial pressures, means that the entire hub cost could be a bit higher. Though that integration with the emitters, the transportation, plus a large storage site. And then we need to, of course, at the early stages where the industry is in its embryonic stage, we need to be extremely close to the policymakers in ensuring that there are policies out there to enable these CCS hubs. So these are some of the key factors we take into consideration when trying to assess and outline the success factors for a CCS hub. I hope that's answered the question, Arthur.
Yes, it does. Thank you. I'm going to need some help from Daryl to relay some of them to me. But I do have a second one that I saw. the important one here is what kind of perhaps something from a question directed more to our steel colleagues. What kind of market do we need to see in order to be able to really stimulate market for low carbon steel? Andrew Purvis, please.
I think that's a really interesting question, Arthur, because clearly we do need a market for these low carbon products. Because the reality is they cost more than making steel or cement or other materials in a conventional way. We are starting to see that in some ways that possibly we didn't anticipate. A good example of that is some of the startup steelmakers which are looking to set up operation in Europe, who are really trying to build in offtake agreements almost from before the plants are built, that allows low carbon materials to flow into customers that they can then bank on that to justify investment. So I think that's an interesting new angle. We need this demand, and I think one of the challenges we've got is to move demand for low carbon products away just from premium, high-end niche into much more mass market, because it's, cost is a lot more of a challenge when you're selling steel into a company like Toyota, who are selling mass market cars, versus, say, BMW or Mercedes. But I think there's certainly the beginning of that conversation. One challenge that's there is, I think, around definitions and standards, because it's one thing to say we'd like to see low carbon steel purchased. Green steel, I don't like to use that expression myself, but then you ask the question, well, what's that? What's low carbon steel? How are you defining low carbon steel? And there isn't at the moment a global understanding of what that is. Now, I'm not sure that there will ever be a global single standard that defines what low carbon material is. But I think it may be that customers themselves will start to be as de facto regulators in terms of their own demands. But certainly a conversation around standards as it applies to low carbon products, I think, would be very helpful. But we're certainly starting to see demand, and that's prompting some supply of this kind of material.
Thank you very much, Andy. That was thanks for addressing this complicated question. I will ask a follow-up a little bit later, if I could. But let me go now to another commenter's question. I see a question here about the creativity and innovation, especially in chemistry. What is it that the petrochemicals industry, Philip, that the industry is in terms of looking at new chemistry pathways, green chemistry pathways? Can you talk a little bit more about that? What is there to incentivize looking at new chemistry?
I find that a difficult question. So we are basically looking at how we can become more circular. But we have products that have really a lot of advantages. The plastics we produce, they're lightweight. So they save on CO2 just to transport things. They keep our food. You can keep it better long. So what is important is that products as petrochemicals, we're producing these basic building blocks for these polymers. There are no easy substitution, and saying the volumes of plastics that we use will suddenly start to use some other kind of material that doesn't have any negative impacts. But what we need to make sure is that all the negative things about plastics, which are they end up in the environment, which they shouldn't, they're at end of life landfilled. This is what we need to stop, and we should go for a circular model where we keep the carbon molecules moving around, where we innovate in a way to go to zero emissions in the end, because that's the target, at least in Europe. Make the design, and then we're talking more downstream, where sometimes the complexity of the way our plastics are used make the material very difficult to recycle. So it's rethinking with the customers how the products should be designed, that they're easy to recycle. I think that's, from a petrochemicals point of view, more important than develop all kinds of new molecules and eliminate all plastics. But that's my personal opinion. But we're quite innovative, and also to take the example of the capture of CO2, the first thing is you have to capture it. So as a chemistry, we're developing better solvents that make that you need less energy, and that you can do it in a more environmentally friendly way to capture that CO2. And that's also chemistry.
Thank you very much.
The situation will be very different for specialty chemicals, where new types of molecules, but then we're talking the low volumes, safer molecules, and that's definitely ongoing. The chemistry is a very wide sector and very diverse. I talk for the petrochemicals.
Yes, thank you very much, Rick. It's good that you made that distinction. Thank you. Okay, I do have a question about, in fact, for Rick. Rick, you made a comment about 70,000 miles of pipeline. So obviously that kind of resonated with one of our audience members. And she actually is asking you, what do you see as ways to the barriers to start to remove those barriers to start building these pipelines? Can you elaborate a little bit more on that?
Sure.
Rick?
So if you think about it, that pipeline infrastructure is going to cross a great number of states here in the United States. And that can only happen with the approval of the federal government. And that can only happen when we have politicians and policymakers who are willing to actually look at solutions. It is a big ask because, as you can tell, communities are very reluctant for any type of industrial add-on. So if you think about it from a plant perspective, telling a community that you want to install carbon capture, they're going to have immediate concerns about it. And this kind of dovetails with the issue of permitting. So the public has to become part of the solution. And whether it's increasing the number of transmission lines that are crossing states, whether it's more acceptance and adoption of lower carbon materials, whether it's approval of pipelines going through their communities, those are all things that the public they have a very strong role to play. And if they're not involved, we'll never see this happen. So this is education, it's awareness. And I tell people, we look at global warming as a societal problem. We cannot solve it by silos among academia or government or industry. It will take a whole of society approach. So that's really the only way we can get there. And until we start with that mindset, we've got a real uphill battle.
Thank you, Rick. That addressed the question, I believe. So thank you. I have another commenter who now wants to switch a little focus now to the other side, not just government stakeholders, but how about shareholders? And I'll address this question to each one of you. Okay, can you let the audience know a little bit more about investors' interest in this, and how in the different industries represented here. What do you detect as some of their thoughts about delivering, say, petrochemicals, steel, and cement with lower greenhouse gas carbon footprints? What are the investors saying to you in these industries?
Well, if I could, I'll start off.
Please, right.
Look, the investors, there is investor pressure, but by the same token, our industry, at least in the United States, and I think it's true worldwide, the cement industry wants to make these substantial changes. The frustrating thing is that we see these obstacles in place, and sometimes the investors aren't as sensitive to those obstacles. So our message to the investors is, again, help us help you. And we're asking the investors to partner with us when we speak to, in particular, the federal government, to be our advocate to make these things happen. And if you think about it from a larger standpoint, when we look at solutions, it's almost like the seesaw that you would see in a playground. On the one end, you've got the process side, including carbon capture, including energy efficiency. On the other side, you have the product side, so making lower carbon materials. You can't have just one approach. You have to have an all of the above approach. Likewise, when you're looking at support for these things, you can't just go in there as only industry or as only investors. You've got to have a whole of society approach. So I think the sooner that people come to that realization and start working cooperatively, the sooner we'll get to solutions.
Great, thank you, Rick. And others, please?
I think
maybe I'll go ahead.
The scale of the transformation that we're talking about is staggering. Mm-hmm. And when I look at the issues around, what we need to do as an industry, a big issue that comes up repeatedly is financing. We're looking at increasing our capacity as an industry, and the cost of doing that depends who you talk to. It seems like carbon accounting, it depends what the rules are, but it's hundreds of billions, up to some people say trillions, depending on when you draw the lines. But I look at our members, I look at particularly their communications with their stakeholders, their investors, their investor day presentations. This whole topic of climate change and sustainability, I think, is increasingly becoming embedded in everything that we do. I think back to my World Steel's General Assembly, which we bring together our members, our CEOs, to really have some strategic conversations around the future of the industry. And the topic of climate and sustainability is now, I think, embedded in everything we do. Everything from safety through to customer discussions, through to how we can decarbonize the industry, energy supply, raw materials. It's all coming together. And I think the role of the investors as part of that is it's a vital conversation that we as an industry need to have with lenders, for example, who are looking to decarbonize their portfolios to be in line with international agreements. How we can create vehicles that allow transition, because in many cases, we're not going to leap from where we are now to low carbon as a step change. There will be a number of incremental investments over quite a long time to get us to where we need to be. But those investments need to happen if we're going to make the big transformation. So I think without talking about individual shareholders and companies and their relationship with their shareholders, I certainly see that conversation around investment and transition is certainly very high on the agenda in many of the discussions that we're having.
Thank you very much, Andy. Yeah, and how about Philip?
Yeah, so obviously there's also this drive following legislation where there is a carbon tax that is driving us to invest in these low carbon technologies. The issue is which is the right technology and at what moment should you invest, So we see that a lot of us are investing in making sure they're connected to renewable electricity and starting to electrify. The CCS, everyone is, these are very complex projects. If you take the Antwerp at Sea project, You have to have 9 companies, each of them capturing their CO2, work with the Port of Antwerp that is going to build the right infrastructure to export it then to Norway, make sure that in Norway they're ready to accept all that. So those are difficult projects. In the meantime, you see a lot of things going on hydrogen and hydrogen firing, and that avoids emitting the CO2. And we have these other pressures, like I said, the plastic waste, and therefore we go to more recycling. In that way, we can avoid that we have to burn it, bring it out. So I would say, yes, the legislation is pushing us to invest, and people are looking at it. And some projects will go quicker than others, and CCS is probably complicated. But on the CCU, there is pilot projects being built of making the CO2 and the hydrogen into olefins. So things are moving.
Great. Thank you very much, Philip. Let me ask Nit to also comment, and then I think Rick actually wants to say something additional as well. So Nit, could you comment a little bit about shareholders to our industry?
Yes, thanks, Arthur. So just for complete disclosure, so I do not work for an oil and gas company or for an energy company. So I'm more an environmental sustainability organization. Though in terms of what my views and what I'm seeing with the oil and gas companies and the investors, they're exceptionally keen on ensuring that these oil and gas companies do move to a net zero world in a specific time frame. And the oil and gas companies are motivated by this, and they are moving towards net zero. Also, the oil and gas companies and these energy companies do understand they have the skills and the expertise for geological CO2 storage and the transportation of CO2 at large scale over land. And they are trying to work collaboratively with the various industrial sectors that do emit CO2 in terms of reducing that CO2 emissions and removing CO2 emissions from the atmosphere and then storing it geologically. So some sort of very keen collaboration to ensure that other industrial sectors can get to net zero as well. And this is being keenly driven by the investor sector and the investors in these organizations. Yeah, great. Thanks, Arthur.
No, thank you. Thank you very much, Ned. Rick, you indicated to me you have some additional thoughts on this, please.
Yeah, both Andy and Philip talked a little bit about low carbon products, and I think Andy was talking about, what does that look like? I just wanted to point out that is a concern because that seems to be a moving target. So, for example, if the government says, well, you have to be in the top 20% of lowest carbon materials to sell your product. Well, that's a bit arbitrary because does that mean that if you're in the top 21%, you're not a low carbon material? Well, of course not. So I think industry, as we look at the definition of low carbon materials, we'd like to make sure that the focus is not just on a product, but it's on an entire system. So obviously, cement is used in concrete. When we talk about carbon, we prefer to talk about, well, what is the total carbon budget for a building, for example? Because there's a carbon footprint between the glass, the steel, the concrete, the asphalt, whatever the building material is. But if we don't take an overall approach to reducing all of carbon, using all the various levers, then we're really missing out on an opportunity, and potentially we're unintentionally making the situation far worse because we end up with products that don't have the strength, the durability, the longevity that we've come to expect, regardless of what that building material is. So I just wanted to point that out. I think perseverating on only the product misses the forest through the trees.
I think that's right, Rick, and it pushes us towards really trying to advocate a life cycle approach to these things. And I think there's a danger as governments and others look to define low carbon products that this happens in silos, because the reality is our products across this webinar and across society are both competing but also synergies. You can't really build buildings out of concrete without a lot of rebar. So there's a synergy there. In other areas, there's direct competition between aluminium, steel, and cement and steel. So we need to make sure that whatever we come up with, it works cross-sectorally. So when you make an assessment of what's low carbon cement or concrete look like, it needs to be in general terms looked at the same way as you look at steel or chemicals or aluminium, so that society as a whole, I think, can take those sensible choices. And an LCA approach seems one way potentially that could be done.
Right.
Couldn't agree more.
Thank you, Rick and Andy. What you just said brings to mind another question here that I see in my queue here of questions. There's been several commenters talking about regions and governments. So there must be, and of course there are, differences in how governments and regions, different countries approach this whole issue. So let me ask a little bit more specific one. In terms of CCUS and working with your industry, do you see any issues right now that perhaps prevent your companies, your members in your association to work with CCS? Any regional differences right now in that?
I mean, I think certainly there are regional differences, Arthur, and we're going to see that, and that comes from regulation. It comes from the frameworks that companies are operating in, the competitive environment I mentioned before. Within Europe, there's been a big shift towards hydrogen, and that looks like that's going to be the dominant, not the only, but the dominant solution. You look at other parts of the world, I'm particularly thinking about China and India. They're building blast furnaces now, and the age of that fleet is young. For those countries to reach the targets that they've set, and the companies to set the target to reach the targets that they've set, so a technology like CCS, for me, feels like it will play a larger role in India and China, for example. Now, what needs to happen? There's a few things I worry about in terms of decarbonizing emissions for our industry as a whole. One of those is infrastructure. I think that's really important. I think you can reasonably expect a steel company to look at capture, to look at how they can capture CO2 on their plant and route it to the gate, if you like. We then need some government, broader societal planning around infrastructure. How do we take that CO2 away? How do you convert that into an OPEX that you just pay for the CO2 and off it goes and it's dealt with? So I think that's really important. And I think permitting came up earlier as well. That's a really important point that I think doesn't get enough attention. Getting permits for industrial facilities can take a very, very long time. And we need regulators, I think, to take a risk-based approach to regulation. And by saying that, I don't mean an irresponsible approach. We take risk-based approaches to everything, every day, and everything we do as businesses. And I think it's reasonable to expect regulators to say the same approach and work with us as we move forward to try and make these changes. Because I mentioned this before, I think the scale that we're talking about is absolutely astronomical in terms of where we need to get to. I think 2020, I think Global CCS said there's about 36 million tons of capacity for CCS in the world. According to the IEA Net Zero, we need to get to 2.9 gigatons only for heavy industry by 2050, which is an 8,000% increase. So we need to see governments, regulators making this possible. And I think a big role of that is infrastructure, and a big role of that is making permitting practical and risk-based.
Okay, great. Thank you very much, Andy. I know we're very close now to the end of at the top of the hour. So, as much as I would like to have continue this fantastic discussion between our panelists, which was great about this regional differences and permitting. So I'll let Andy have that last word. Really, the permitting is such an important part of deployment of CCS technologies and other technologies to get these plants to really reduce their carbon footprint. So I'll turn it back over to Amy Collins to bring us home. Okay, Amy?
Thank you, Arthur. Yes, unfortunately, we've come to the end of the hour. I'm sure we could have kept on with that discussion. Really, really interesting insights there. So thank you very much, Navasan, Andy, Philip, and Rick for your excellent presentations and for being very open during that Q&A. And thank you, Arthur, for moderating as well. And thank you, everyone, for taking the time to listen online and ask your questions. I think we got through quite a lot there. So hopefully we've been able to answer them. So as mentioned earlier, a recording of the webinar will be sent to you afterwards. If you do want to get in touch with us, then you can visit our website or our social media pages, which you can see on the slide there. And please do listen in to any of the recordings for the other webinars we've been holding in this series. They've been really, really interesting. So thanks again, everyone, and have a great rest of your week. Goodbye.